evening friends, myself Gautam Sharma and I welcome you all in our Sapiens education. For more information please visit our website www.sapienseducation.com. For any type of query you may also comment in the comment section. Okay, today I am going to teach you part 4 of the laws of motion, and that is motion of a body in a lift, equilibrium of a particle, and concept of a free body diagram. Okay, so let us discuss everything one by one. I hope you will able to understand now. See, topic to be covered in these videos are equilibrium of a particle, concept of free body diagram, motion of a body in a lift, inertial and non-inertial frame of reference, and application of a pseudo force while solving numerical. I hope you will able to get maximum. I will try to make you understand in this class. Okay, now what is equilibrium of a particle? So first of all you need to think by definition. Equilibrium of a particle in a mechanics refers to the situation when net external force of the particle is zero. For example, a body, suppose there is a body, right, and a force is acting from here, F1, force is acting here from F2, force is acting from F3, F4. Numerous of force are acting, right? Numerous of force are acting. If numerous of forces are acting, and if total net force is zero, and net moment about point is equal to 0, then this body is in equilibrium. Body is in equilibrium. Very important. For example, at first I will take the body in a rest. For example, this body is at a rest. Okay, this is the rest and its initial velocity u is 0. Now I am applying a force of 10 Newton from this direction and also a force of 10 Newton from this direction. So what will be the net force? So net force will be equal to 10 minus 10, and this will be equal to 0. Okay, this will be equal to 0. Now as per this above situation, body will not get accelerated, no acceleration will be also 0, and body will remain in a rest. Body will be remain at a rest position, right? Now see, second situation may come. For example, a body is here and its motion is 10 meter per second, and when a force is being applied here 10 Newton, and from this direction also force is being applied here 10 Newton, then what will be net force? So net force is 0, and net force is 0, then body, we can say that body is in equilibrium. Body is in equilibrium. Okay, and this implies that acceleration is 0. So if acceleration is 0, then body will remain in its state of a 10 meter per second. If earlier its body's motion was 10 meter per second, after applying a lots of force also, if net force is 0, then we can say that this body has total 0 acceleration, and body does not change its state of its early motion. I hope you all have understood. Okay, now before that I will teach you most important thing for equilibrium. Three important condition for equilibrium. Important condition for equilibrium. You should definitely try to understand this, for it will helpful for your exams or any numerical problems. It means that total sum of force is equal to 0 and total moment about a point is 0. So for example, moment about this point should be 0, or any point. If you will take any point, then the moment about any point should be equal to 0. This total force indicates that not only force if a force, total summation of force is equal to 0 means what? See, I will teach you in a separate slide here. Wait. Okay. Now see here. Suppose there is a body, okay, and there is a force F1 in x direction, F2 in y direction, x direction. So summation of total force in x direction should be equal to 0. Similarly, summation of force in y direction should be equal to 0, and summation of fz direction is equal to 0. It may happens, for example, a body is like this, and it may happens that force is acting in this other direction like this. If force is acting here like this direction, then how you will split in x and y direction? So definitely we know the resolution of vector. So can we resolute this vector in x and y form? So can we write this form? For example, this is your theta, so f can be written in this component as f cos theta and f sin theta, right? If f1 is acting, so you need to write here f1 and f1 and f1. Now let us consider another force f2 is acting with angle theta 1. So this is your f2. So you need to split in x direction as well as y direction. So in x direction it will be f2 cos theta 1, or theta 2. You can write here theta 2 cos theta 2. Okay, and here in this direction it will be f2 sin theta 2. Now for equilibrium condition, now how you will solve this? For equilibrium condition, summation of fx equal to 0 means total force should be 0. So can we write here f1 cos theta 1 plus f2 cos theta 2, it will be equal to 0. So this is the condition. Summation of fy must be equal to 0 for equilibrium condition. It means that fy means what? Y direction. See here, there is f2 is above. In above we always used, in upward direction we use plus sign. So can we write here f2 sin theta 2, and here f1 it is in a minus, so we can write here minus f1 sin theta 1. Okay, so totally we are getting 0, so we can write here 0 and we will get the equation, and after getting some equation you can solve the problem. Okay, so this is the case of an equilibrium. Now let us try to solve one example of NCERT. See here, NCERT what they are telling. See, try to read the question. Okay, now see, a mass of 5 kg is suspended by a rope of a length 2 meter from the ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint of P and of the rope as shown in a figure. See, earlier it was the case like this, and it has how much meter? 2 meter. Okay, and the weight it is your 60 Newton. Why 60 Newton? Because weight is equal to mg. So see, since it has mass 6 kg, so weight will be equal to 60 Newton. Understood? Now a sum of external force is applied here about 50 Newton. So this is the situation what happens here. See, external force, some person or some peoples are applying how much? 50 Newton. If 50 Newton force is applied, then what is the angle of this inclination? We need to find this case. Okay, so how you will do this? So by using equilibrium only, because when he is applying a 50 Newton, at that state acceleration is equal to 0 and body is in equilibrium. Okay, so if body is in equilibrium, then what will happen? If body is in equilibrium, then what will happen? Try to solve this. See, in this situation, if body is in equilibrium, see here, we are getting following diagram. See, let us consider this is a straight line. In this case, in y-axis 50 Newton is there, and in this case it is your T1, and in downward case it is your 60 Newton. Okay, now we know that 60 Newton and 50 Newton are in x and y axis, but T1 we don't know in which axis it is, so we need to resolve this. If you will resolve this, so it will be T1 cos theta 1 if you resolve this in x and y component, and in this direction it will be T1 sin theta 1, right? Now you forget this. If you have split this into two component, you need to take an account of this force and this force only. Okay, so now tell me, as body is in equilibrium, equilibrium, it means the summation of fx equal to 0. So in x direction what will be there? So it is your T1 sin theta 1 is equal to it will be you can write here like this. Okay, now see here, you can write here summation of fx equal to 0. Fx has how much Newton of force? Plus 50 Newton, because it is positive direction in x-axis, minus T1 sin theta, minus T1 sin theta. Okay, and this is equal to 0. So can we write here T1 sin theta is equal to 50? So this is equation number 1. Now we will talk about equation number 2. Equation number 2, it is your sum of force in y direction will be how much? It will be equal to 0 as body is in equilibrium. So can we write here T1 cos theta minus 60 Newton, this is equal to 0. So we get another equation, T1 cos theta is equal to 60. Can we divide both equation 1 and 2? If I will divide equation 1 and 2, T1 will get cancelled. So finally we are getting tan theta is equal to 5 by 6. So you will get theta equal to tan inverse 5 by 6. Understood? Now if you got tan theta, so you can easily find out that tan theta, if you get theta, so you can easily find out T1. What will be the T1 value? So T1 can be written as 60 divided by cos theta, or you can also find it by T1 is equal to 50 by sin theta. 50 by sin theta. I hope you have understood this process. Okay, so this is the method. This is the method you should apply in while solving a numerical problem. Okay, I hope you have all understood now. Now next slide. I am talking about inertial frame. What is inertial frame? See here, inertial frame of reference. A non-accelerating frame of reference is called inertial frame of reference. For example, I am using this frame, and this frame has x-axis and y-axis. Okay, and if its acceleration is 0, either it is at rest or its velocity is constant. Velocity is your constant, then it is called inertial frame of reference. Inertial frame of reference. I hope you have understood inertial frame of reference. What does inertial frame of reference means? Okay, another is your non-inertial frame of reference. So you are taking a reference of either x-axis, y-axis and z-axis. but this whole reference are moving, accelerating in upward direction or accelerating in x direction, accelerating in a z direction, anywhere or any direction, then this type of frame of reference is called non-inertial frame of reference. A rotating frame of reference is known as non-inertial frame. Can you tell me why rotating frame of reference is called non-inertial frame of reference? Because as in a rotation, you know that in spite of being constant velocity also, it's uniformly accelerated motion. So wherever there will be a rotation, whenever there is a frame, if frame is rotating, it means that there is an acceleration, and if it is an acceleration, then you need to tell that this is your non-inertial frame of reference. So these two category I hope you have understood now. Now the very important thing is pseudo force, the concept of pseudo forces. Pseudo force is physically apparent but not non-existence force. It actually does not exist but the felt by an observer in non-inertial frame. Okay, for example, a train, you are sitting in a train and train's speed is 50 meter per second, and another train with the same speed, it is your 50 meter per second. Both are moving, but when you are sitting in this train A and you are watching train B, then it will appear as a rest. Because why? Because of inertia frame, because of frame of reference. Okay, because of relative motion. Okay, so see here, you will able to understand this. See, you will able to understood these things. That actually there is no actually there is a movement, but in spite of this there is no movement. It means that non-existence of in the same manner non-existence of force that felt by an observer in a non-inertial frame. So whenever we will talk about non-inertial frame, so there will be always a non-existence of non-existence of force will be there, which will be felt by observation. Now pseudo force means what? Pseudo force means, pseudo means real, and sorry, pseudo means false. Pseudo means false. Okay, so it is not real. When we draw a free body diagram of a mass with respect to inertial frame of reference, then we can apply the only real force. But when free body diagram is drawn in non-inertial force, then pseudo force is required. So whenever, mind it, whenever inertial frame is there, inertial frame is there, that is acceleration of the frame is 0, then use real force. Use real force. If non-inertial frame is there, then you should use pseudo force and make it equilibrium. Now you will be able to understand it more clearly when I will show you it with the example. So try to understand here when I am showing you with an example. See here, a body has mass and gravity in downward direction like this. Okay, and this body is moving. This body is, when kept in an object, so there will be a reaction force, yes or no? Now this object, where this body is kept, this object is moving in accelerating in upward direction. So it means that this body will feel a force, okay, and this body will feel a force, and that type of force you should note it as a pseudo force, that is F, and F can be written as M into A. Now you make it as equilibrium and try to add all the force into 0. For example, if you are taking in y direction, so you take resultant force plus y direction, and here mg is minus direction, and force you are acting in also negative direction, so this will be ma. So here we can write here reaction force is equal to mg plus ma. See, if this body was raised, reaction force will be mg. If the frame of reference is by self moving with an acceleration a, then it will increase the reaction force. Same way, everywhere you need to solve like this only, okay? Everywhere. If you are taking this body and this body is moving in upward direction, and here this body is moving in upward direction, then how you will solve this problem? And suppose there is a mass m1 and this mass is m2, so you need to find an equation. See what equation? So for this you need to make a free body diagram. You know about free body diagram? Free body diagram means what? We should include all the force acting on that particular object, and we should forget this. For example, I will take mass m1. If I will take mass m1, suppose I am taking a mass m1, and which type of force is acting on this mass? So first of all, the force which is acting is m1 into g, downward direction, that is force due to gravity. Second force which is acting on this object is tension force T. As this body is accelerating downward, so another third force is what? Pseudo force. So you should try to use pseudo force. So pseudo force will be always in the opposite direction of acceleration. So here it will be F is equal to ma. Okay. So totally how many forces are there? Tension force, pseudo force, and m1g force. Now equate this. Since above y-axis you will take positive any quantity with a positive signs, so this will be plus t plus ma, and this will be equal to ma. In case of ma, you need to write here m1a, okay, because the mass is m1. So here m1g, okay. So you will get, finally you will get tension is equal to m1g minus m1a. So this is the method of solving. So if you will get the equation like this, so you will be able to put the value and get the answer. Now I will talk about this this object like m2. So in case of m2, what did you saw here? See here, m2, the gravitational force m2 into g will act in downward direction. Above, tension force will act in upward direction. Since acceleration is in upward direction, so extra pseudo force, that is F, will be equal to m2a, will act in a downward direction. Now by solving this, you need to make this all zero force. So how you will make it zero force? See here, above direction T is the tension, below minus m2a minus m2g, and this will be equal to 0. So finally your tension will be m2a plus m2g. So this is the second equation. So you have understood how to draw free body diagram and how to take a pseudo force. I hope you all have understood how to take off pseudo force, right? So pseudo force concept you have understood it clearly, and free body diagram also. Okay. Now see here. In case of this circular motion, what happens? Tension T is equal to m r omega square. You know this. This is called centrifugal force. Okay. So centrifugal force is acting. and acceleration is in this direction, force is acting in this direction, and total force will be how much? See here, if you I will draw the free body diagram. So how you will draw this free body diagram? So if in a circular motion there is a tension, so tension will be in this direction. I hope this you have understood. And pseudo force or centrifugal force will be m r omega square in this direction, and centripetal force will be how much? So centripetal force, that is F centripetal, is in this direction acting towards center. So if you will add on this, so what you will get? So it will be minus Fc minus T plus mr omega square equal to 0. So from here you can find tension is equal to Fc, tension is equal to Fc or no, tension is equal to mr omega square minus Fc. I hope you have understood this equation. Okay, so in this way you will able to apply a pseudo force. Now let us consider motion in the lift. So as you know that motion in a lift is what? See here, motion in the lift, a person is on the lift, this person is on the lift, okay, and lift is its person's weight is acting downward, that is equal to mg, and reaction force r is acting upward. Okay, so when body of mass is placed on a weighing machine which is placed in the lift, and then actually weight of the body is mg, this force mg acts on a weighing machine which offers a reaction force by the reading of a weighing machine. As we know that as per Newton's third law, every action has equal and opposite reaction. This reaction R exerted by the surface of a contact of the body is apparent weight of the body. Note, this reaction exerted by the surface contact on the body is apparent weight of the body. I will make you it clear now only. Okay, let us consider acceleration is now 0. So take it as a actual. No need to take a pseudo force. Now we will apply a pseudo force when body is in acceleration. Now see the case. See the case when lift is moving upward direction. If lift is moving in upward direction, so what we need to take? We need to take a pseudo force in downward direction, that is equal to ma. So I have got three type of, see, if you will draw a free body diagram, so we are getting mg downward direction, ma downward direction, that is pseudo force, and reaction force is r. So equate this equation to 0. So above you are seeing here r is plus r minus mg minus ma equal to 0. So reaction force is equal to mg plus ma. It means that reaction force is given by if there is a weighing machine, so it may show the reaction force. So when a lift is going upward direction, so reaction force is increased by ma times. See here, earlier it was mg when it was at rest, but when lift start moving in upward direction, so ma is add on. So that's why apparent weight is increased from actual weight when lift is moving in upward direction. I hope you all have understood now. Now you need to think how to solve this, how to apply a pseudo force. Okay, pseudo force very important. While I will definitely come with so many numericals to solve this type of problem. Now in case of a lift moving downward direction, so if lift is moving downward direction, see here acceleration is in downward. So if I will draw a diagram, so you know that mg is acting in downward direction, reaction force in upward direction. Since acceleration is downward, so definitely pseudo force will be that will be ma is in upward direction. So now make it is 0. So take ma plus 1 because it is positive of y-axis, plus r because it is positive at the y-axis, and minus mg because it is of negative of the y-axis, and this must be equal to 0. So from here you can write that r is equal to mg minus ma. It means that earlier it was mg, now it has been reduced. Understood? So when you are at a lift, and if lift is going downward, so you will feel a little bit less weightlessness. It means that apparent weight, the actual feeling of the apparent weight is less than actual weight. So actual weight normally you understood, but lift is going downward, so you will feel at least lightness. Okay, lightness. You will feel light. Your body will be totally light. Okay, understood. I hope you have understood now. Okay. Now there is a here one important thing. Whenever you are solving a lift problem, you have to take lift mass as well as your body mass as a combined mass, and by this only you need to apply in the equation, and you will able to solve this. Okay, I hope you have understood. I hope you have all have understood these things. So whatever what type of topic I have taught you today. First of all, equilibrium of a particle, concept of free body diagram, motion of a body in a lift, inertial and non-inertial frame, application of a pseudo force while solving a numerical. Again, I want to repeat a free body diagram, very important. Free body diagram, very important. Free body diagram. While solving a problem, while solving any type of problem, let us take a body is like this, and another body is above this, and it is moving downward direction. Okay, and force is acting in this direction. So there are two mass, there is m1 and 1 and 2. How you will solve this type of problem? So first of all, you need to take a free body diagram. So I am just taking a one object 1. So what type of in object 1, what type of force are acting? See, object 1 has a mass m1, so it will be in a downward direction. See here. See, you need to take like this. Okay, free body diagram. So above, see here, it is your m1g. M1g will be m1g. M1g will act in downward direction. So this will be, for example, there is an angle theta of a, so it will be m1g cos theta, and if you will split this in this diagram, so it will be m1g sin theta. Okay, and since, see here, when this object is moving in downward direction, so this means that lower object is also applying a force on object 1. So lower body is object 2 and upper body is an object 1. So lower body is applying a force. Which type of force it is applying? Frictional force. Which type of force is applying? Frictional force only. Okay, frictional force. So how many force you have got? m1g sin theta and frictional force, and you know that reaction force is r only. So reaction force and m1g force, this will be what? R1 is positive minus m1g cos theta is equal to 0. And if you will see this case, so this will be your m1g sin theta plus frictional force is equal to 0. It means that frictional force applied is equal to minus m1g of sin theta. Okay, so this is the free body diagram of a body 1. Now I will talk about this body 2. I am doing with the color 2. So this is a body 2. So in body 2, see here, body 2, how you can able to draw this body 2's free body diagram. So see, this is the structure. Okay, so now you know that it has how much mass? It has how much mass? So definitely m2g only. Okay, now if you will split into two components, so this will be m2g cos theta and it will be your m1g sin theta. Okay, and there will be a reaction force in this direction. Okay, reaction force will be suppose there is a reaction force and it is called as R2. Now tell me which force is acting here. F is force is acting. If it is coming down, so frictional force will be act here in this direction. So in this way you need to take all the force which are acting on this body. Suppose this body is moving in downward direction, so definitely this smaller one will apply in upward direction force, so there will be another frictional force from F1 from this body. So all the force, whatever is type of whatever force is being applied on this body, you should show this force and you should add on to 0. You will get the equation, and by getting an equation you will able to solve this problem. I hope you have now understood how to solve, how to make a free body diagram. So I will come with the friction. When I will teach you friction separately, then I will solve so many numerical only. Okay. So I hope you will able to understand more and more. For further more details, wait for my next video. I will definitely solve all the problems related to laws of motion, and I hope that you will definitely feel confident and you won't find any type of difficulty while solving any type of numericals. Thanks for watching my videos, and please comment in my comment section if you are getting any type of problem. Thank you.